and tell you it's time to record.
Gosh, and it makes me so nervous. Oh man, we're moving along here. Third
Yeah,
day.
Third day.
Third day. Yep. A little raspy this morning.
Oh,
I guess that's what happens when you talk for 2 days straight.
That's
right?
what happens. Yeah.
Yep. And drink a little too much beer.
It's to be expected.
To be expected. Yep. Yep.
Still can't keep up with these Germans though, man.
They are nuts. And the Aussies.
Yeah, the
And the
Aussies too.
Kiwis. All of them.
Yeah, all of them.
Yeah. Yeah. Note to self. Don't try to keep up.
Yeah, right.
Yeah. All right. Let's get this going real quick, if you would. I'm excited to have this conversation. Just give us your name, who you're with, and what you do.
I'm Andrzej Slinsky from Synergize, and I'm the community evangelist for Copernicus Data Space Ecosystem.
Community evangelist. I like that title.
Copernicus Data Space
Ecosystem.
Ecosystem.
Okay, you're going to have to tell us a
Tell
little
us
more.
yes,
about
Yes.
that.
And Copernicus, right? That's the satellites and sort of geodata evidence-based policy program of the European Commission.
Yep.
Data space. Now, a data space is a place where you can get your data, but you can also process it straight in the cloud.
Okay.
We have a lot of other data spaces, like there's this data space directive, but so we are a data space, and ecosystem is because we want to build this into an ecosystem. We've got industry partners now who have joined the ecosystem, who have connected to us. We have users small and large. So we are like one big ecosystem, a family.
So when you say ecosystem, does that mean all of this data is shared amongst all of the people that are putting the data in the cloud?
Yes.
Okay.
In a way, we are like a real ecosystem. I'm an ecologist by training.
Okay.
So in this sense, Sentinel data is like sunlight, right? It's just given for free to everyone. It's out there. All the data is ready to be accessed. There's no wait. And then different, systems, different people build their own livelihoods on top of it. And then they are consumed by the carnivores who are eaten by the top predators. So in a remote sensing sense, this works like we have these mid-layer service providers who take our free data, they add an algorithm on top and they sell it to farmers or public authorities or whoever. We've got some big system integrators who take a lot of data from various sources. They make big machine learning processes and then they offer that. For example, we've got World Cereal, so global mapping of agricultural produce in more than 20 categories. This runs on our cloud. This takes our data. It uses the OpenEO API, and it's got some really heavy machine learning that's also running on the cloud in there.
So it's like the days of data silos is going away.
It's going away.
Yeah.
This is something for everyone. And we also have the tools that can connect data from different backends now. So that's a big deal. Back a couple of years ago, if you wanted to use one API, you had to go to that backend. If you had an account on one backend, you could only use that API.
Okay.
Now this is gone. This is gone.
So what problems is it solving for people?
Well, not all of the, but most of the obstacles of data access. So I remember when I was a PhD student and I could finally convince my advisor to buy me a gamer laptop. I was super happy with that. I mean, I was king of the lab. It was a biology lab. So I had this pretty fancy thing with the red lights. You don't need to buy a big computer anymore because the commission has done that investment. And I mean, for students hacking around, that's nice. But for somebody who wants to build a startup, that's a game changer because that means you can really start offering a product without actually having to first buy a server or to buy some desktop software. So this kind of scaling obstacle is really nicely removed. And the other big deal is I think this is becoming a standard, an interchange platform. So again, the transferability of Earth observation pipelines is a big deal. Somebody's built something. Is it going to work on my site? Is it even worth testing? Now we've got 450,000 users at the moment.
Oh,
so
wow.
this is a big platform. We are actually connecting people. So it's worth using this for interchange. If you build something with our APIs or on top of our data, it's ready to be shared. It's ready to be reused. And this is just massively growing the field.
So I'm guessing this is, you said, this big, huge data set, right? Is this ongoingly updated and just constantly being refreshed? And how do you manage that?
Yeah, well, we have at the moment somewhere around 90 terabytes of data. And with the Sentinel satellites in orbit, we get, I don't know how many every day, but it's a lot. So that's regularly updated. It goes into our data storage, into our cloud, and it's in this cloud optimized GeoTIFF format, most of the data. And that means that you don't have to do much more processing because you do your processing on the fly. It's not compressed, it's streamed. So you submit a request, then the API takes the data immediately for your area of interest, for your bands, and it even applies the calculation, the visualization, the classification, whatever, as part of your API request. So it's not like you download the data and then something runs on your computer. It's actually all happening in the cloud, all on our server.
So you
it's
say, give
wicked fast.
me this square and give me, you know, this classified, and you tell it what to do. And then that's how it comes to you.
Yes. And it doesn't even have to be a square. It can be a weird shape that you upload with a JSON.
What's the coverage area of the data you have? Like, is it all of Europe?
Well, it's global, most of it. It depends on the sensor because, you know, you've got these inclined orbits that don't exactly cover the poles, and some of the data, like now we're going into autumn. So Sentinel-2 is not really imaging the northern latitudes anymore because there's no light. We have some things with the Sentinel-1 acquisition plan that it's not perfectly global either, but I would say 95% of the data we offer is global.
And how often is it updated?
Depends on the sensor again. So a lot of the fastest data set we actually have is the Copernicus Land Monitoring Service temperature data set, which is updated hourly.
Oh,
It's collected from geostationary satellites, and it's a product of the Copernicus Land Monitoring Service, but it goes up on our system with a 3-hour delay, and it's there.
So who owns the satellites?
Well, that's part of Copernicus. So the Copernicus program is this big commitment of Europe to actually operate an Earth observation program on the long term. And this is publicly owned. It's a civilian system. So in that way, it belongs to the member states of Europe.
And the data that's available, is it just imagery or is there more to it than that?
Oh, there's more to it than that. Actually, a couple of months ago, connecting the Copernicus Land Monitoring data store to CDSE was this big deal. This is the downstream data. So it's actually calibrated products for various vegetation parameters, but also things like soil moisture, temperature, snow cover. This is the data you actually use, right? So many people are not interested in the satellite image. They don't want to do the processing, but if it's there for them, and if it's a, if it's a robust, calibrated thing that you can verify with a white paper, then they're going to use it. So that's what we hope.
It's almost like, they're not getting the photos to then calculate snow cover. They're just getting the data of snow cover already coming straight from it.
Exactly. Of course, if you want to calculate it from
the
images,
that's
you can do
available
it because
too,
the images are there as well.
Why redo the same, redo the same work, right? Since it's already available.
Yes, it depends on your use case. For some use cases, it's better to have your own little algorithm, or it may be optimized for a specific place, or you might want to have higher temporal or spatial resolution. Specifically for snow cover, we've got different users. Some of them use the standard product and some of them create their own. So this happens. And it's also an entry step, right? You check the standard product, you start working with it. It's going to be rather good, but it's not perfect. And then you think, okay, now, is it worth going the next step? Is it worth actually investing in developing an algorithm of my own from the data that I have?
So who are your typical customers or users?
Well, in terms of numbers, most of our users are, I think, students. So we have Copernicus Browser, which is this open browser-based tool for looking at satellite images. That's now heavily used both in high school level teaching, but also in university teaching. So somebody who just wants to look up something on a satellite image. But in terms of data volume, our heaviest users are probably agricultural monitoring. So we've got in Europe the Common Agricultural Policy, and I think monitoring that is probably the largest civilian application of Earth observation worldwide. Every EU member state, every agricultural parcel, and the data definitely comes from our platform, but now more and more paying agencies are actually moving to doing the processing on the platform as well, since it's free for them.
Yeah,
interesting.
How many organizations like this are there around the world, or how many? Because Copernicus is a constellation, right? How many constellations are there? Aren't there other ones? And
I don't know how many there are now, though.
Does other? I guess my question is are you unique in the space of? Are there other groups like yours that do it for the constellations in Asia or North America?
Yes, well, JAXA has their own data space. I don't know if that's also as advanced in terms of cloud processing and integration, but they have their data space and they have their own satellites. USGS and the Landsat program is there, and NASA has their own viewer, and that also includes some cloud processing. But as far as I've seen, that's less targeted at sort of the common user.
Yeah. So why? Or I mean, is it just to provide a better benefit and more value to the data that everyone already technically owns?
Well, yes, I think you had to bring together a couple of things for this, and also the time had to be right. So when cloud optimized formats became a thing, then data streaming became available. That already happened a while ago. And then, of course, you need a big backend. So you need storage technology to be ready for this. And then you also need the application side. You really need to bring this close to the user. So this is how we are a consortium actually of Cloudflare, which is a Polish cloud provider, Synergize, who are the minds behind Sentinel Hub, T-Systems, who are doing a lot of the architecture. They also have the Open Telecom Cloud, which is a different platform behind this, and Vito, who are on the application side, and they are also the ones powering the OpenEO API. So this is how we sort of come together, and then Isa and the commission asked us to do this.
And is this like it? What's the business model? Is it like a subscription, or is this all open source?
You get a subscription, which is open to anybody for any purpose. And with that subscription, you get a quota. That quota is 10,000 processing units. And one unit it can be represented by a tile of 512 by 512 pixels and 3 layers. And I think it's an 8-bit integer data. So and you get 10,000 of that. So that's already, you can process whole countries with that for free. Ways you either have to get a commercial subscription, or if you're a public authority, you're an agency in Europe who are working somehow towards the Copernicus services, then you're eligible to get a free quota extension.
Oh, wow. So basically, if you're a startup, you could start using it, make sure it works in concept, and then once you have that commercial application, then you could upgrade to that commercial user.
Yes, exactly. And then you're still only paying for the processing units and for the virtual machines that you're using. It's not like you have to buy a big box. You can have it growing as you move forward.
And you're not paying for the data technically.
No,
you're
absolutely
just paying for the processing.
No, it's all yours.
Yeah.
Wow, that's amazing. And what role is AI playing in this?
Well, we are really looking into serving AI as much as possible. People tell me the biggest obstacle for AI is still the data wrangling. You have to get the data in a format where the AI is able to chew it. And so for this, we are serving data mosaics. We are creating quarterly mosaics from Sentinel-2, and we are creating monthly mosaics actually from Sentinel-1. And then that's seamless, that's corrected. So it's a very smooth and robust data set, which is regularly produced, and AI can really nicely eat that. So that's one of the things where we contribute. The other side is in the downstream, the application side. This API I was talking about, OpenEO, also connects to ONNX. ONNX is this interchange format between different deep learning models. So it has what you call a model zoo. You can take a pre-trained model, and it's still going to connect straight to the API. It's going to take the data in a streamed way, so you don't have to build a big database. And it works. We have also produced some embeddings for Sentinel-2 for one year of Sentinel-2 as an example. It's available on Hugging Face. So we are really trying to move forward with this to create the data that the AI people can run on. Oh, and there's one more thing actually. I'm not much of a coder, but now I'm doing a lot of coding with the help of AI. And since the code base is so big and the documentation is rather solid, AI is now super smart in actually understanding that and helping common people like me to actually get coding with satellite data.
So even you could do it.
Yeah,
I'm sure.
Yeah, I'm sure. It's faith in me.
Yeah.
What else? I mean, this is very exciting, very intriguing. How do people find out more?
Well, I think the easiest way actually is our YouTube channel. We have a website, of course. We've got our social media. We've got our LinkedIn. There's 2 easy ways in. One is to get experimenting with Copernicus browser. Just open browser.copernicus.dataspace.eu and get experimenting, play around, open up something. Yeah. But the other is this YouTube channel, YouTube/Copernicus Dataspace Ecosystem, where we have tutorials from really beginner level all the way up to the actual code base.
Awesome.
You know what I was just thinking of? Remember the lady we talked to earlier about she has the app that helps people have the safest route downtown based on all the different data metrics. Like this may be something that well, probably she's already using, but still
super cool. Yeah, it's awesome. Anything else you want to get out there?
I think I'm fine. Well, yeah, we have a roadmap. There's stuff coming up. We're actually going to integrate bi-monthly composites of Landsat. Again, there's big demand for historic data for climate change investigation. And so a lot of people have been kicking us for Landsat. It's political because, I mean, why would you have a European infrastructure actually serve as a hub for Landsat? But then this solution was found that we are taking a downstream product. It's actually created by guys over at Intergeo, where they take 2 monthly composites of Landsat, and that goes all the way back into the historic archive. So that's now already in our Stack browser, and it's going to come also for the visualization.
Wow.
You're like a human computer.
That's amazing.
Trying to keep up, but all good stuff. Thank you so much for your time. Really appreciate it.
Yeah. Thanks for stopping by.
Thank you for
Sure.
the opportunity.